So today our topic is Karl Pearson's coefficient of correlation. Before starting this topic, I want to give you a brief insight what we have done in the last lesson. We have done the meaning of the correlation, covariance and type of the correlation. So far we have done one type, that is scatter plot, and second type is Karl Pearson coefficient of correlation. It is also called the Pearson coefficient and the product movement correlation of coefficient. So property of this coefficient of correlation is that it is denoted by the small r and its values lie from the +1 to -1. If you are getting a value +1, it means you have a perfect positive correlation. But if you have a -1, it means you have a perfect negative correlation. And if you are getting the value 0, it means there is no correlation between the two variables. Now the second property is it is independent of change of origin. And third is it is independent of change of the scale. What is origin? What is scale? Whenever we are adding and subtracting a constant value to the variable x and variable y, it means it will lead to no change in the correlation. Your correlation will remain the same. Same applies with the change of scale. It means whenever you are multiplying and dividing some value means the constant value with the variable of x or the variable of y, you are getting the same correlation of correlation. There will be no change. That's why it's called it is independent of change of origin and it is independent of change of the scale. Now the fourth property is it is geometric mean of the two regression coefficient. What is regression coefficient? That we will learn in the next chapter. That is the simple linear regression, right? So we will not discuss it here. Now next is the assumption of the correlation of coefficient. Now it is said to be a linear relationship. Why? Because whatever change leads to one variable, in the second it should be constant. So whatever we can see in the graph, it should be in a straight line. Suppose we have some equation. This equation is called the linear equation, right? If I put some value in this equation, suppose y is equal to 4x plus 6. It means there are some constant already in the equation. And if you change the value of x, you are putting 1, 2, 3, 5, 6, 7, whatever value you are putting, it leads to value of the y. So whatever changes you can see in the value of x and y and you plot in the graph, you can see the single line, single straight line. It means your relationship between the variable is linear. Second is your data should be normally distributed. Second is there is a cause and effect relationship between the variable. Whatever variables we are studying, there should be some logic behind it. Suppose in the last question we have done the weight and relation. We want to establish a relationship between the weight and height. But there we haven't find any relationship between the two in this scatter plot, right? So yes, there is some cases where we can find it. Now you can suppose and take an example. If I want to establish a relationship between the number of divorce cases in the country with the television buying in the country, is there any logic behind it? So we can't take it that into account to for the correlation. So every time we keep in mind that there should be some cause and effect relationship. Now the last note is whatever value we are getting from the R, they always tell us the two parts. One is the direction of the coefficient of correlation and second is the magnitude of correlation, right? So magnitude is equal to strength, also strength of the correlation, and the plus and minus sign will show the direction. Here's the sign is the negative. If you see the value of R is equal to minus 0.85, it means you are getting the negative relationship between the two variable, but the magnitude of the two variable are very high, so they find it very strong relationship between the variable, right? So if we look at the question on the Karl Pearson's of coefficient of correlation, it is done on the basis of the direct method. What is the direct method? When we take the deviation from the actual mean of the variable, right? So I took the same example where we have done the covariance. So here we have done already the value of mean value of the x and mean value of the y, which is given in this. X is 62.5 and mean value of the y variable is 108.17. Then small x here is denoted as the deviation taken from the actual mean, and small y is taken as here as the deviation taken from the actual mean of the y. Now we took the product of the small x and small y, and then we have taken the whole square of the small x and small y square, and we find all the sum of all the given variables and put it in the formula. In the formula we have to just put it the sum of the product of the x of y and the square under root sum of the x square into sum of the y square, right? So I just put it all the value in this formula and getting the result of 0.61, which is lie between the strong positive correlation. I advise that every time you calculate the value of R, you will interpret your result how strong the relationship are, right? So this is the another question. Here I want you to take a pause in this video and attempt this question by yourself and find it if you are understanding it or not. So it is very simple question or take hardly 30 seconds to solve it. So the question is, the coefficient of correlation between two variable x and y is 0.48 and their covariance is 36. If variance of x is 16, find the standard deviation of y series. Look at the variance of x is 16 and need to find out the standard deviation of y. Now pay attention carefully that there are variance and standard deviation. Now you have to convert it variance into standard deviation, right? So we can't take into account variance as the standard deviation. So we will convert the variance of x into standard deviation of x. So that is 4 and put it in the formula, that is the given formula, and put all the value and find the rest value which is standard deviation of y, and you get the standard deviation, which is very easy, right? To avoid this complicated task and to save our time, we put this formula. So what this formula is, it's look like very hard, but after simplification we get this formula, right, which is given below. Now there is another problem. So I have variable x and variable y, and I calculated the mean value of variable x and mean value of variable y, which I got 74.86, and for y it's 125.5. If you can see, if I take it as actual deviation, I take the deviation from the actual mean, all the value come in the decimals, right? To avoid that complication, I assumed a mean. So in the x and y, I assumed 69 and 112 as the assumed mean and find out all the deviations, right? So dx I denoted that the deviation from the assumed mean, and dy is the deviation from the variable y. After calculating all the parts of the formula, I put it all the values in the formula and I get the result of 0.95. So I suggest you again interpret your result. This 0.95 shows a very strong relationship between the x and y. So now this is only the two method we need to do in the correlation of coefficient. One is doing the direct method and second is doing the correlation coefficient using assumed mean.